Part one, AP Lab, number 13. I know it's not number 13, but that's what it is. That's your reference. Okay, so calculate the average initial temperature of the hot and cold water. Record this temperature as TAV in data part 1. So let's see, I had temperature average. I had, this is the top, I have 22.9 plus 61.1. And I divide by 2. So I got 42.0 degrees. Yours is going to be a little bit different.
I know, but is it? Oh, that's not right.
What's that? 42.0 degrees Celsius. So in the average, I put 42. The line that says average. Took my hottest, normal, that's my average. Okay? Okay. All right, number 3, number 4. Number 4 says the difference between T average and T mix. All right, is it asking you to do that or does it tell you that? What's number 4 say? What's the question? What's 4 say?
The difference between T average and T mix is due to the heat lost by the water and absorbed by the calorimeter.
All right, the heat lost by the water is, all right, Q of the water equals grams times C of water times delta T. And delta T in this case is going to be the T of the mix minus T of the average. Okay? So in order to calculate that, QH2O, I have grams. What are my grams going to be? 100 grams. All right, times 4.184, 4.18 grams per, you know this, and my mix minus my, all right, mix minus my average is going to be 42.0 minus 41.5, so I got 0.5. So I did 41.5 minus 42. Put that right there. Okay? And then my Q of my water will be, for me, negative 200 joules. Yours is going to be different, but it should be in the ballpark, plus or minus 200 or so. Should be in the ballpark of that. All right, so that's my Q of my water. So, right? So then my Q of my cal equals my Q of my water. All right? And when you do that, the calorimeter is going to be Q cal is going to be what? Opposite of this, positive 200 joules. All right, sorry about that. Things kind of acting up a little bit. So you should kind of be in that ballpark. Are there any questions on that? Yes.
I'm not ballpark.
What are you? What'd you do here? You this and this had to be the same.
Yeah.
Okay, what'd you have here?
0.1.
So you had like, okay, so then you got,
Like 41, 40.
okay, that's
Is that
fine.
fine? Okay.
I said plus or minus 200.
Oh,
From what I'm at.
Okay, I see what you're saying. I thought you meant between.
Your data can't, your data drives your answers.
Yeah, but
When I did it, it's a little bit
if we
different.
use these numbers,
Okay?
we should.
You're fine. As long as you have, as long as you weren't, it was positive 0.1, right? Or
Yeah.
negative. Mine was negative. Negative 0.1. Negative, right?
Negative.
Yeah, so you got negative, you switched it over to positive. Perfect, you're fine.
I got one.
Okay, next, number 5, calculate the heat capacity of the calorimeter, C-cal. This is equal to the heat calorimeter absorbs when 100 mils of solution changes 1 degree in temperature. So C-cal, all right, C-cal is going to be Q-cal, which we just did, T mix minus T initial. All right, and it's telling you to do it in joules per degree Celsius, so C-cal, very simple. It's not that complicated like you're trying to make it. 200 joules divided by, 22.9 degrees Celsius. It looks a lot simpler than what you probably tried to make it. Joules per degree Celsius.
Is your initial the heated initial before you start?
The heated, this initial 22.9 is going to be what I did for right at the my
Room temperature?
yeah.
Okay. So we have 37. We got 8.3.
Yeah, that's fine. As long as you're plus or minus like 5 or 8.
That's what we do is we do our room temperature and then we take our mix.
Well, yours is going to, what you have here.
So this minus this.
21.
And then
What do you have here?
39.
39 and 21. But you got a different number here.
Yeah.
Yep.
We have a huge number for my Q now. We have almost
You got what?
585 for Q now.
Okay. I mean, if your numbers match up, there's nothing I can't control what your calculations and your thermometer read. Like I can't. You just have to know how to do it based on the data that's given to you. Right? Okay. Part 2. Do I have any questions? These are questions. These are what they'll look like on your test. Okay? So if you can kind of get the gist of that, and what we're doing here for the part 2 and part 3 looks like I might be finishing part 3 after, not today. I'll go ahead and start part 2. Okay, calculate the enthalpy of reaction delta H. So you have to graph the temperature versus time on a separate sheet of graph paper for each of the 3 reactions tested. Extrapolate the line back to find the instantaneous mixing temperature, T mix, for each reaction. Record that in data table 2. Right, so that's how you would do that. Extrapolate it back. Draw the line. Calculate the amount of heat evolved in each reaction. View of the reaction if it is assumed that all heat of the reaction is absorbed by the solution and calorimeter. Then, all right, did they give you the 2 equations? Q of the reaction, negative heat absorbed, and then where T of the solution, they give you that, right? Assume the density, yeah? Nick was asking me this question. All right. Okay, so we're going to get to this part. Record the Q of the reaction. All right, so number 1, we have NaOH, aqueous. They don't give you this, right? They get, okay, so, okay, yeah, all right. NaCl plus H2O. And that's going to be a liquid, can't be aqueous, liquid. All right, so we have to figure out D delta T of the solution. All right, so what would the delta T of the solution be? For me, I did 35. All right. If you have your homework, it is right there.